Hey, and welcome back. We're going to talk a little bit more about magnetism today. And to help us do that, we see this little diagram of a horseshoe magnet with a north pole and a south pole. And by convention, as we saw in our diagram of the Earth from our previous video, the field lines go from north to south. Now, something interesting happens when a charged particle is moving inside this field. So I'm going to draw a little positively charged particle. And we're going to imagine this positively charged particle moving down in that field. If it's moving down in that field, it actually will feel a force from that field. So again, it's moving down in our picture. There's the direction of the velocity. And it feels a force from the magnetic field because the charged particle is moving. Now, the first time I heard about this was news to me, but you will find out later in our discussion of magnetism that that is the source of magnetic fields, moving charge. But for now, let's just suffice it to say this moving charged particle moving in the magnetic field feels a force. Let's ask ourselves, what factors determine how great that force is? So take a moment, hit your pause button, and think about what factors will make that force have the magnitude that it has. And we're back from our pause. And what factors do you think determine the size of the force? Well, if you thought how much charge it was that was moving, of course that has something to do with it. If you thought how great the velocity it was that it's moving, that naturally has something to do with it as well. But clearly, force cannot equal Q times V, right? Force does not have the units coulomb meters per second. There must be one other thing that matters. And what might that other thing be? Take a moment and think about it. That one other thing, of course, is the strength of the magnetic field, which gets the symbol capital letter B. Now, one other thing also matters. That's the direction of the velocity relative to the direction of the magnetic field. And theta is that angle, the angle between the direction of velocity and the direction of the magnetic field. So in this case, what is that angle? If you just look at your picture and sort of take it as literally as you can, what might that angle be? Take a moment. That angle, of course, is 90 degrees. If we look at our picture, we can see that that's certainly what's implied. And we also know that the sine of 90 degrees is 1. So in this example, given Q, given V, and given B, we have the greatest force that we can possibly have. So this is our equation. F equals QVB sine theta. That's the magnitude of the force, equals the magnitude of the charge times the magnitude of the velocity times the magnitude of the magnetic field strength times the sine of theta. So let's take a moment and figure out what the units for B must be. Rearranging the equation, and let's take sine theta and say that it's 1, as it is in our simple case. Then B must equal F over QV, giving us the units newtons per coulomb meter per second, or, if you prefer, Newton seconds per coulomb meter. Well, a Newton second per coulomb meter, that's a mouthful, right? If we're going to talk about the strength of magnetic fields, and we will, we want an easier way to talk about that. Luckily, this unit has been named after a very famous individual, a great scientist from the turn of the last century who actually lived right here in New York City for a great deal of his life. His name is Nikola Tesla, and the unit is the Tesla. And here to introduce the unit is Nikola himself. He's so famous they made a puppet of him, and hello, and Nikola Tesla, honored with the unit Tesla, which is the unit for the magnetic field strength. So back to our moving charged particle in our magnetic field. We know that the magnitude of the force it feels is related to how much charge there is, how much it's moving, how great the field it's in is in, and the angle between its direction of its motion and the direction of the field. We'll talk more about not just the magnitude of that force, but of course the other very important component of that force, that is its direction, in our next video. Thanks for watching.